Okay, so let's go ahead and take a look at the odd number problems from this problem set. Okay, so what we're going to do is we're going to find the limit at a point. So I'm going to look at something like this. And if I can plug in 2 in for my x in this case, you know, because I'm looking at x equals, or x as x approaches 2. If I can plug in 2 and not get 0 in the denominator, then I'm going to go ahead and do it. So this is just 2 to the 4th, which is equal to 16. Now let's be clear. I have to write the limit notation down every single time until I'm just plugging in the actual value. Okay, so here again, there's no denominator with question 3 here. So I'm going to go ahead and I'm going to plug in -3 in for my x. And now remember, I could have done this with synthetic division. So I could have done -3, 2, 4, and 1, and whatever I got for my remainder will actually be what this limit is equal to. So 2, -6, -2, +6, so 7. So this limit is equal to 7. Okay. Moving right along here. Now, here's where I'm going to get into a situation where if I plug in -1 in for my x here without doing anything, I'm going to get 0 in the denominator. So I have a few options. Remember, our options are factoring, simplifying the complex fraction, multiplying by the conjugate. There is one other technique, but we'll look at that a little bit later after we do the next unit. So now I have to actually write the limit notation, because what I need to do is I need to factor my numerator to get rid of my issue in my denominator with 0 being in the denominator. So now I'm going to go ahead and I'm going to cancel out my x plus 1. So I'm left with the limit as x approaches -1 of x minus 1. Now I can go ahead, because there's no 0 in the denominator, I'm going to plug in -1 in for my x, and I get -2. Okay. Here, there is actually no x, so as x approaches 15, this is just the square root of 2. Let's look at 8 for just a second. This is simplifying the complex fraction. So go ahead and take a look at the notes for this question. The complex fraction. Question 9 is multiplying by the conjugate. So we're going to multiply by the square root of x plus 5 in the top and the bottom. So multiplying by the conjugate turns my my equation into a difference of squares. So I get the limit as x approaches 0. Because I'm turning this into a difference of squares in the numerator, what I have is the square root of x plus 5 squared minus, oops, this should be a square root here, square root of 5 squared, all divided by x times root x plus 5 plus the square root of 5. So now what I get is I get the limit as x approaches 0, and I get an x plus 5 minus 5 all over x times root x plus 5 plus root 5. Oops. And now my x plus 5 minus 5 cancels out with my x in the denominator, so I get the limit as x approaches 0, 1 divided by the square root of x plus 5 plus root 5. Now when I plug in 0 in for my my x, I don't get 0 in the denominator, so I get 1 divided by root 0 plus 5 plus root 5, which is 1 to square root of 5. And I don't need to simplify by rationalizing the denominator. That's totally fine. Okay, so now I'm going to look at question 11. And when I'm looking at the limit as x approaches -3, what I end up with is I need to look at, remember we did left side and right side limits. So I'm going to take the limit as x approaches -3 of negative, from the negative side, of the absolute value of x plus 3 over x plus 3. And what I get is I'm going to be plugging in values of x that are smaller than -3. So in my absolute value, that's going to be always negative. So I'm going to have the limit as x approaches -3 from the negative side of negative x plus 3 over x plus 3, which gives me a negative 1. When I do it from the right-hand side, negative, I get the absolute value of x plus 3 over x plus 3. When I drop my absolute value, I'm actually going to drop it and leave it as a positive. So this becomes x plus 3 over x plus 3, which gives me a positive 1. Those two are not equal, so this overall limit does not exist. Okay? And then, so we look at 13, which follows the same suit as kind of like number 12. And I'm only going to do a couple of these just so that you guys can see. But I'm looking at, the limit as x approaches negative 3 from the plus side. So that is here at negative 2. And then my g of x is here at positive 2. So I'm adding those together. So negative 2 plus positive 2, which gives me 0. The addition here, what I could have done is I could have written this as the limit as x approaches negative 3 from the plus side of f of x plus the limit. So I could have separated up into two limits. And that's why I can do my negative 2 plus 2. And that's how I can separate those up. I could do the exact same thing here, limit x approaches negative 3 from the negative side of f of x, and then minus 3 times the limit as x approaches negative 3 from the negative side of g of x. So then I would have been down here at negative 2 for my g of x, and I would have been at 0 for my f of x. So I would have 0 minus 3 times a negative 2, which would have given me a positive 6. Okay, so hopefully you guys see the pattern with all these. And that's it for this problem set. Let me know if you have any questions.